Okay, so today we are going to look at decimal multiplication, and we're going to use these hundreds grids to represent a decimal times a whole number, and then we're going to look at a decimal times a decimal. So we're going to start with the problem. Let's do 3 times 32 hundredths. Okay, so one of these squares in this grid equals one whole, and each one is broken into 100 different little squares, so each of those squares equals 100th. So if 1 equals one whole and one little bitty square equals 100th, one of these bars is going to equal 1/10. So I look at my problem and I see 3 times 32 hundredths. So that means I need to take these little squares and I need to color in 32 hundredths 3 different times. I have to represent that number 3 times. So I'm going to take my first color. I'm going to look at my decimal. I'm going to see how many tenths I need in total. So I want to take that and I want to color in 3 tenths to start with. So I have 3 tenths, and that will equal 30 hundredths. Then I'm going to take my 2 and color that in. So I have 32 hundredths. Okay, now I'm going to take a different color, and I'm going to represent my second set of 32 hundredths. So if I have to mark it out, I can definitely do that too. 1, 2, 3, 4, 5, 6, 7, 8. That gets me 8. So this whole row will give me 18. This whole row will get me 28. I'm just skip counting by 10. 29, 30, 31, 32. And I'm going to color in those bars, or those boxes. Okay, so now I have 2 sets of 32 hundredths, but I need 3. So I'm going to take my third color, and I'm going to go ahead and count out another 32 hundredths. 1, 2, 3, 4, 5, 6. Plus 10 gets me 16. Plus 10 gets me 26, 27, 28, 29, 30, 31, 32. So I can color all those in. Okay, so on this graph, this hundredths grid, I have represented 32 hundredths 3 times. 1, 2, 3. So my product for 3 times 32 hundredths, I'm going to count up the number of squares I have shaded in. And I can count up my tenths first. So 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths. And then I have 1, 2, 3, 4, 5, 6 hundredths. So my product for 3 times 32 hundredths is going to be 96 hundredths. Now I want my kids in my class to check their answer using the standard algorithm, or just multiplying the 2 numbers together. So I'm going to move over here, and I'm going to take my 32 hundredths, I'm going to multiply it times 3. 32 hundredths times 3. Now when I'm using the standard algorithm to multiply with decimals, my first step is just to multiply like the decimal isn't even there. Just pretend it's not there and multiply like normal. So 3 times 2 is 6, and 3 times 3 is 9. Okay, my next step is I'm going to count the number of decimal places, the number of numbers, the number of digits I have behind my decimals. So on my top row, I have 2 numbers behind my decimals. So I'm going to write a 2 here to the side. On my bottom row, I have 0 numbers behind a decimal. I don't have a decimal on the bottom. So I want to add those 2 numbers up. 2 plus 0 is 2. So I need to move my decimal place over 2 times. So my answer, my product, will be 96 hundredths. And I look over here and I have matched it. So this problem is correct. My model is correct. Okay, let's do one other example of that. So let's do 4 times 19 hundredths. So I need to represent this 19 hundredths 4 different times. So I'm going to shade in 19 of these hundredths. So that's 1/10 bar and 9 of the little hundredths in the next row. Okay, so that's my first set. My second set, I can go ahead and shade in 1/10 bar. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now my third set. So I can shade in 1/10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's 3 sets of 19 hundredths. So now I need to do a fourth set. So 1, 2, 3, plus 10 is 13, 14, 15, 16, 17, 18, 19. Excuse me. So on my hundredths grid, I have represented 19 hundredths 4 times. So I'm going to take my answer, my model, and I'm going to count up the number of hundredths I have shaded in. So 1, 2, 3, 4, 5, 6, 7 tenths, and 1, 2, 3, 4, 5, 6 hundredths. So my product of 4 times 19 hundredths is going to should arrive at 76 hundredths. So I'm going to come over to my other side. I'm going to check it using my standard algorithm. So 19 hundredths times 4. 4 times 9 gets me to 36. 4 times 1 is 4, plus 3 is 7. I have 2 numbers behind my decimal on the top row. I have 0 numbers behind a decimal on the bottom row. So 2 plus 0, I arrive at 2. So I need to move my decimal over 2 times. So my product is 76 hundredths, and that's what I arrived at over here, so I know my answer is correct. So let's look at multiplying a decimal times a decimal. This was multiplying a decimal times a whole number. Now I want to multiply a decimal times a decimal, and this is where it can get kind of tricky. So when I'm multiplying 2 decimals, let's use the decimals 4 tenths times 3 tenths. My first decimal is going to tell me how many rows or columns I need to shade in going up and down. So my first number, I have 4 tenths. So I'm going to shade in 1, 2, 3, 4 different lines, 4 different tenths. So I'm going to take that and I'm going to shade it in. Okay, so I've shaded in my first decimal. Now my second decimal, my 3 tenths, tells me how many rows going side to side I need to shade in. So I need 3 tenths shaded in, 1, 2, 3 tenths. I mark that like that so I know how many I need to color. I told them that in class, so I hope that's a strategy they use. So I'm going to shade in those 3 tenths going from side to side like that. Now, I'm going to take a darker color and I'm going to count up the number of spots or number of hundredths that are overlapping and that are shaded with both colors. So when I take my pen, I'm going to X out or put a mark or dot in each of those boxes as I count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is the number of hundredths in my product. So my product of 4/10 times 3/10 should arrive at 12 hundredths. Now I'm going to check my answer using the standard algorithm. So I'm going to set it up just like a normal multiplication problem. I have 4/10 times 3/10. I'm going to multiply like normal. 3 times 4, the product is 12. I have one number behind my decimal on the top row. I have one number behind my decimal on the bottom row. So 1 plus 1 is 2. So I need to move my decimal over 2 times. So my product is 12 hundredths, and that matches what my model said, so it is correct. All right, let's do one more example of a decimal times a decimal. So let's do 7/10 times 4/10. So 7/10 times 4/10. My first number tells me how many rows to color in going up and down. 1, 2, 3, 4, 5, 6, 7. So I'm going to take those and I'm going to color in all of that. Now I use 2 different colors, so it makes it easier for me to see which ones are shaded and which ones are overlapping. It works better if you use 2 colors that, like red and blue, they change to purple, but it's okay if you can, as long as you can see where your overlapping part is, that's all that matters. Okay, my second number tells me how many rows going side to side. So I have 4/10, so I need to shade in 1, 2, 3, 4 rows side to side. Okay, so now I'm going to take my darker color and I'm going to count and put a mark in every hundredth that is overlapping and shaded with both colors. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So my product of 7/10 times 4/10 is 28 hundredths. Okay, now I'm going to check my answer once again using the standard algorithm. So I'm going to line up my problem. 7/10 times 4/10. 4 times 7 is 28. I have one number behind my decimal on the top row, one number behind my decimal on the bottom row. 1 plus 1 is 2. So I need to move my decimal over 2 times. So my product is 28 hundredths. That's what I got over here, so my answer is correct. My model is correct. So that is how you use a hundreds grid or a model to represent multiplying decimals.